Okay, section 5.5, it's not labeled up here, but this is page 22 in your notes packet. Printed that off and downloaded it, page 22, okay? All right, so we're going to work with double angle and half angle formulas in section 5.5. We're actually not going to use product to sum and sum to product formulas. Once again, just we got to trim some fat here, and we're not going to have time, so that's gone, this section. Okay, and these are actually kind of like identities, and we skipped identities in section 5.1.5.2, so you can cross out 1 through 4. We're not going to address those problems this year either. Okay. Okay, so for problems like number 5, it says use the given conditions down here to find the exact values of sine of 2u. It's called a double angle formula. So if we peek at that formula, we need sine of u and cosine of u. Right now, we're missing sine of u. We only have cosine of u, but we can definitely use our chapter 4 skills to take care of that. It's basically going to be the same steps we did yesterday. So if you just want to reference that again, instead of writing these all down, where we want to draw a sketch for the angle, get our exact values we need, and then we just use the formula. Same steps. So maybe you even want to make note of that. Same steps as, what was that, example 12, I guess? Example 12 in section 5.4 notes. So I don't think we need to rewrite it again. Let's just reference it here. Okay, same as steps as example 12 in 5.4 notes. All right, so let's go ahead and draw this scenario. Angle U is greater than 3 pi over 2 and less than 2 pi, or 270 to 360 if it helps you to kind of put those in degrees. They're referring to the fourth quadrant. The angle is rotating around and ending somewhere in here. Okay. All right, so what I would suggest is get a reference triangle made with the x-axis. Cosine is x over r, so here's my x value. Y is going to be negative when we find it, and then the hypotenuse is 5. All right, this happens to be a 3, 4, 5 triangle again, so this is negative 3. Okay, so I have cosine u already listed. Maybe I'll just put the other ones down here. Sine of angle u will be negative 3/5. Tangent of u will be negative 3/4. And now I can go ahead. There's basically 3 parts to this, right? They're asking us for sine of 2u, cosine 2u, tangent of 2u. Double angle formulas. All right, so I guess I'll just call this A, B, and C. Why not? Sine of 2u, and I'm just writing down the formula up there. This is also on your formula sheet that I gave you. You might say alpha or beta instead. So here we go. It's equal to 2 times sine of u. Sine of u is negative 3/5. I'm going to write 2 as a fraction right now, 2 over 1, just so everything gets lined up and it's nice and neat. And then cosine of u is given as 4/5. And I'm just going to multiply this fraction. This one's pretty easy to simplify. So I've got the 2 times the 3, 6 times 4. I get 24. It is negative. All right, and then down here I get 25. It's important to put that 2 over 1 because some students, if they don't, they end up multiplying the 5 by 2 and they get 50. No, it's just 1, okay? So negative 24/25 is reduced. That's my answer. Okay. All right, now the double angle formula for cosine actually has options. That's why it's listed this way. They could have written this many times, cosine 2u, cosine 2u. All right, it has different forms. They're just giving you options. If, for example, you only have the cosine of u, you could use this formula. If you only had the sine, you could get away by using this formula. But this is the easiest of the 3. All right, so I'm going to star this one. I recommend using this one whenever possible. It's easier to simplify. All right, so because squaring fractions is real easy, and then we subtract them. So I'm just going to rewrite that one down so we know what we're using. Cosine squared u minus sine squared u. So cosine was 4/5. And that's how they show to square cosine u. Basically means, it's kind of new here, isn't it? that means sine of u squared. It's just a shorthand way to express it if you put the exponent right there, okay? So these are the same. Same thing with cosine. So 4/5 squared minus sine of angle u squared, which was negative 3/5. Okay, tangent needs a little more space. I'm going to try to go to the right to save my space down here for tangent. So to just square these, when you square a fraction, it means 4/5 times 4/5. Or square the top, square the bottom. So I get 16/25 from that one, minus, and then this gives me 9/25. All right, notice how it's still minus. Some of you guys get too antsy on that. You see the minus negative, want to make it plus. No, we square first, and the squaring the negative makes it positive, and I still have to subtract it. So 16, we got a common denominator, so 16 take away the 9. We end up with 7/25. That's the answer. Okay, and so cosine has 3. Like I said, this is my recommendation. Tangent doesn't, sine doesn't. We just use the one we're given. All right, so moving on to the tangent of 2 theta. So tangent of 2u equals, now it's right there on the paper. I'm not going to rewrite the formula here. Let's just jump right into it. It says 2 times the tangent of u. So I have 2, I'm going to put 2 over 1, times tan u, negative 3/4. Okay, that's in my numerator. On the bottom, it says 1 minus tangent squared u. So negative 3/4 squared, like that. Okay. All right, let's simplify and multiply the top. So we get negative 6/4. I'm going to reduce it right now. Why not? 2/4 is 1/2. So that's negative 3/2. The bottom I can't subtract yet until I square. So I'm just going to write 1 minus, and then let's square this. I get 9/16. Your call here. We could go ahead and eliminate the fractions right now, or I could go ahead and make this 16 over 16, right? Get a common denominator and get 7/16 and multiply by the reciprocal. Totally your call. I guess I'll do both. All right, so I'm going to go ahead and subtract these. 16/16 minus 9/16 is 7/16. And up top, I've got the negative 3/2. And then let's multiply by the reciprocal. So I have negative 3/2 times 16 over 7. So that gives me 8. 24 over 7. Negative 24/7 is the answer. Okay, yeah, maybe if you multiply straight across, you get 48 over 14, but then that can be reduced. I just reduced the 2/16 right now. Or I'm sorry, 16 over 2. All right, so the other option, if you want to multiply by 16, I'll just show you this real quick. You can write it down or just watch. If I multiply this by the common denominator of 16, these cross reduce. It gives me negative 24 up top. And then if I multiply by 16 down here, 16 times 1 is 16. And then 16 times this, those cross reduce and give me minus 9. So right away, I get the negative 24, and then 16 minus 9 is 7. Whatever method you like. I don't care. We just got to do it right. Okay? Okay, your turn to try this. I'll kind of push you in the right direction on 6, and then you can try this on your own. Now this one gives us some information about cotangent. Okay, it says quadrant 1, 0 to pi over 2. So that's kind of where your work is going to start. Get a sketch going in the first quadrant. Remember, this is cotangent, so right away, we know tangent of x. I should have said u, actually, right? Because the angle u and it put x, so I guess scribble out the x and put u there. So tangent of u must be 12/5. Let's use that to our advantage to get maybe a sketch going, find the unknown side, and then find the other two. And go ahead and start. Maybe after just a couple minutes, check in to see how you did on sine. Make sure everything's set up right before you go on to cosine and tangent. Here's just a checkpoint to make sure things are going good. 13 should have been your hypotenuse. I don't sketch that different spot, but anyways, cosine u is 5/13, sine u is 12/13. So here's the answer to the sine double angle. 2 times the product of these two. So we should get 120 over 169. Okay, continue on. Try the cosine 2u and tangent 2u. Give you about 3 minutes. All right, here's cosine. Once again, this is the one I prefer. I'd stay away from the other ones. I could go through it, but don't need to. I just push it to the easier one. Okay, so here we get 25 over 169, 144. Subtracting with the common denominator, we get negative 119 over 169. All right, and then the tangent of the double angle. This is what we get. Okay, my work this time, I actually decided just to multiply by 25. Common denominator, it's really easy because this reduces to 5 over 1, 5 times 24, 120. Fraction's gone right away. Okay, on the bottom, same thing, 25 times 1, 25, 25 times this, it's gone. I'm left with 144. Fractions are gone, and it's just an easy approach. Okay, so here's where these double angle formulas are on your sheet. And we got 3 options for cosine. This is the preferred one. Okay, and we also want to introduce half angle formulas today. They're right here. Tangent has, once again, 2. You don't need both of them. Might just want to do this on your formula sheet. Just use this one. I probably won't even refer to that one, okay? All right, so let's go ahead and take a look here at a half angle formula. Here it is here. So that's the one I'd just maybe scribble out. You don't really need it. All right, next we want to start with the one that has a number. So 7 and 8 we're going to save for Monday. Let's jump to number 9. Use half angle formulas to determine the exact values for sine, cosine, and tangent of that angle. All right, so remember for sum and difference formulas in section 5.4, we had problems like this and we had to re-express it. Like 105 right now does not have a good reference angle if we were to draw that. But so before we wrote that as 45 degrees plus 60 degrees was one option. And that's still an option to find the exact value. But sometimes we want to use the half angle formula. You'll see why in other numbers where that's not an option. For this particular one, we do have options. But anyways, we're going to use the half angle formula. All right, so what we want to do is write that as an angle over 2. Okay, we want to write 105 as an angle divided by 2. All right, so in order to do that, to keep the value the same, we double it. So 210 degrees divided by 2 is still 105. Okay, so you see the half angle approach, that's how we kind of rewrite it. Double it, and then turn back around and undouble it, divided by 2, and they're equal, right? Okay, and now 210, usually they give you a problem like this. This number is going to have a good reference angle. We can work with 210. I can find the cosine of 210, sine 210, whatever. All you guys can. All right, so let's just go ahead and do one at a time. I'm just going to rewrite the sine formula. I'm just rewriting this down on paper right here. Okay, sine of theta over 2 equals plus or minus the square root of 1 minus cosine theta over 2. Okay, so what do we need? Really, to figure this out, I need to find the cosine of theta. In this case, it's 210. So right now, 210 is going right here and here. So to apply this, it's going to be, I'm just going to write it right below, sine of 210 degrees over 2 equals plus or minus the square root of 1 minus the cosine of 210 over 2. All right, so I need the cosine of 210. I'm going to do that in the next video.